Hello and happy Thursday. If you guys are watching this means I'm out today because I'm not feeling well. I'm hoping I will be back tomorrow. So let's go ahead and get started with our area of a circle and sector notes. Remember, as we work or at the end, to be filling in whatever you need in terms of area on your summary sheet. So given circle O with arc length of AB being 3 over 2 pi, find the exact area of the shaded region. So we were given that arc AB is 3 over 2 pi. That right here is our arc length. Now let's think about it. What are we going to need in order to find area? Well, we're going to have to do some subtracting, and we have a big circle, so let's go ahead. We need to figure out what our radius is in order to help us. Well, is there an equation or formula that deals with arc length that also involves radius? So take a moment and think about that. Pause the video, and I want you to try the warm-up. Okay, hopefully you were able to successfully complete the warm-up. So let's go ahead and continue on. So our arc length formula is arc length equals theta over 360 times 2 pi r. Well, lucky for us, we know our arc length and we know the measure of theta because it's opening, 90 degrees is opening towards arc AB. So this is going to be 3 pi over 2 equals 90 over 360 times 2 pi r. Because of this, I can now find my radius. Take a moment and solve. $90 times 2 is $180. 180 divided by 360 is 1/2. So this becomes 3 pi over 2 equals 1/2 times pi r. If we multiply everything by 2, we're left with 3 pi equals pi r. The last thing I need to do is go ahead and divide pi by both sides, and we're left that we have a radius of 3. Awesome, so we know that our radius of the circle is 3. So let's go ahead and figure out what's the area of my circle. Well, area formula is pi r squared, so this will give us 3 squared times pi, which equals 9 pi units squared. Awesome. Now, I want you to think about how much of this shaded region makes up our circle. Well, because it is 90 degrees of my circle, and we know a circle is 360 degrees, well, 90 is 1/4 of your circle. So the area of your shaded region is 1/4 of the area of your circle, which gives you 9 pi over 4 units squared. So we can say that the area of my shaded region is 9 pi over 4 units squared. If you have any questions, please jot them down now so you can ask me tomorrow. All right, area of a sector. Sector is a region bounded by 2 radii in an arc of the circle, a part of the area of the circle. So in this image, that area that I just highlighted is your sector. It's your part. So if we think about this and we call this angle measure here theta, well, we can also say that the measure of arc AB is theta, which means the measure of angle ACB is also theta. Theta is a part of the circle, and we know how we find the area of a circle. It's pi r squared. What you need to do to find the area of a sector is you're going to take that arc measure or angle measure, so theta in this case, divided by 360, because that's a full circle, times that area of a circle. And this is going to be my area formula for a sector. Pause the video if you need to, take a moment, write it down, whatever you need to do to be successful. All right, let's take a look at example 1. Given circle H with HE equals 4. Okay, that also means HG equals 4 because they're both radii. The measure of angle F being 50 degrees. Determine the area of the shaded sector. Okay, so there's a few things we need to do here. We need to figure out, in order to find the area of the shaded region, we need to first figure out what the area of the circle is, and then we'll subtract whatever the area of this sector here is. Well, we need a few pieces of information. We know our radius, so we can find the area of the circle. But for that sector, we have to figure out what the measure of angle EHG is. Since the measure of angle F is an inscribed angle and it's opening up to arc EG, we know that that inscribed angle is going to be half the measure of the arc. So this will be 100 degrees along with our arc measure of 100 degrees. So let's go ahead and solve. The area of my shaded region is going to equal, well, the area of my circle here is 4 squared times pi minus the area of my sector. Okay, we said the area of the sector formula is the angle measure, so 100 divided by 360 times the area of the circle, which is 16 pi. Take a moment and solve. So pause the video, try and solve it, see if you get the same thing. So we should get the area of my shaded region is going to be 16 pi minus, okay, well, 100 divided by 360 times 16 is 40 pi over 9. We don't need to round or anything because it's not asking for decimals. So the area here is going to be 16 pi minus 40 pi over 9 units squared. Write down any questions if you have them, so you can ask me tomorrow. Pause the video if needed. All right, I want you to take a moment, read through example 2. Given circle J with a radius of 4, and the measure of arc IK is 2 pi over 3. Determine the perimeter and the area of the shaded region. So we have to figure out the perimeter of the shaded region and the area of the shaded region. So to start, to find the area of our shaded region, we need to first find the area of the sector, right? Because our entire sector is going to be this part here, bound by 2 radii. So the area of the sector minus the area of your triangle. So this part right here. All right, well, how do we figure out what this could be? Take a moment, see what you need. In order to turn the measure of arc IK into an angle measure, I should have just given this to you. So from the start, if you weren't sure, this will be 120 degrees. If you do remember from Algebra 2, you can do 180 times 2 divided by 3, and it gives you 120. So sorry about that. I should have given that to you to start with. So this is 120 degrees, meaning that since this is in the middle, this angle measure here will be 120 degrees as well. Well, how does that help me? Well, that helps me because I know my radii. I know that in this triangle, if I drop down an altitude, it's an isosceles triangle. So let's off to the side draw our triangle, JIK, just so we have some more room. So we know that these have measures of 4, this has measures of 4, and if we were to drop an altitude in that isosceles triangle, it's going to bisect the 120, meaning this is going to be 60 degrees, this will be 60 degrees, and this will be 30 degrees, and this will be 30 degrees. Not only that, but it also bisects this side. So go ahead, take a moment, compare it to your 30, 60, 90 triangles. 4 is across from your 90-degree angle, so that's technically equal to 2x, meaning that x, the side across from your 30-degree angle, will be 2, and the side across from your 60-degree angle will be 2 root 3. Because it's bisecting, we know that both those sides are going to be congruent. So the base of my triangle, so IK, will be 4 root 3 with a height of 2. Based on that, can I find the area of my triangles? Yeah, we can say that the area of my triangle is 1/2 times your base of 4 root 3 times your height of 2. After calculating that, we should get that the area of my triangle is 4 root 3 units squared. All right, well now how do we figure out the area of the sector? Well, we know the radius. We know the angle measure in which the sector is opening towards, so we can then find it. So the area of my sector will be 120 over 360 times my radius squared, so 16 pi. Go ahead, take a moment to calculate this. So my area of my shaded region is going to be, 120 divided by 360 times 16. That'll give me 16 pi over 3 minus, and then we had our area of the triangle, which is 4 root 3. It's not telling us to round, so that'll be my final answer of units squared. All right, good. So we found our area of the shaded region. So now what we need to find is our perimeter. So in order to find the perimeter, we need to add IK, so the distance between IK, plus the measure of arc IK. Well, we know that the distance of IK, we just solved it in our triangle, is 4 root 3. But the arc measure, arc length of IK is going to be 120 over 360 times your circumference, so times 2 pi 4. When we simplify this, we get 4 root 3 plus 3 pi over 2. It's just perimeter, so it will be units. Go ahead, take a moment, jot down any questions you have, if you have any. Now I want you to pause and try additional practice number 1. So pause the video. All right, let's try it. Circle A has a radius of 12, where the measure of angle DAB is 80 degrees. Find the exact area of sector DAB. We know our radius. We know that angle measure. So the area of my sector is going to be 80 over 360 times my area of the circle, so 12 squared times pi. So this will end up equaling 2 over 9 times 144 pi. After simplifying, we should get that the area of my sector is 288 pi over 9 units squared. That was a pretty straightforward one. So now your job is to write down the area of a sector and circle formula on your summary sheet. So I expect you to do that. And you can now get started on homework number 7.